Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself Mallesham Devasani, you can call me as Deva sir. I'm the best CS and IT mentor on Unacademy, where you can access to all my free classes by using DEVALIVE referral code, and this is also code for an entry to Unacademy, or you can use for the plus or iconic to get 10% discount. So this is about my referral code. DEVALIVE is my referral code, and today in this session I'll be starting the most important topic for the competitive exams here, GATE. Every year at least 2 marks definitely comes from the undecidability, and we have studied definitions, and that is too important before starting this session. If anybody attempting or attending this session directly without attending the previous session, I recommend you to go for first definitions, understand them, and come to the problems now. Yeah. So here we are going to look at, we understood the words in undecidability concepts. Now we are going to apply them on the problems. Then how to apply them we are going to see. Right? Yeah. Good evening, Arpan. Yeah, Satyajit, good evening. Good evening. Guys, like the session if you are watching this video. And if you want to know about me, you can read my profile, and I work as an educator on Unacademy, and I worked in various institutes, and before that I have completed my MTech from IIT Bombay. I get a lot of students throughout the country. So many cities I have visited to take the GATE classes, and here on Unacademy you can see that you will see C programming, TOC compiler, algorithm, discrete mathematics, some of the subjects that I have already taken on Unacademy, you can find out. And this is what my referral code talks about, DEVALIVE. So it is important if you want to take the subscription, and this is not for my courses, it is for to get an access to any course from Unacademy, remember. So that is very important. Okay. Yeah, good evening Shubhastri, good evening. And in case if you are not aware of plus and iconic, plus you will get an access to live interactive classes. They are all structured. Every subject is well planned, is disciplined before starting the course. How many days we are going to take, 40 days, 45 days, every day timing, and which day doubt session, which day quiz, everything will be announced before starting the subject. So you can plan very well during your preparation. And you will have weekly tests, doubt solving in each subject that you study, and you will have the courses in both English and Hindi from January onwards. So we will be announcing soon about the courses, so then be ready for that. And iconic, additional to plus, you will be assigned with a coach, and you will have a separate study material when you have a problem, and you have a booster session, study planner, test analysis to boost your confidence. In case if you want to know what are the classes I have taken, you can find more than 400 classes on Unacademy which are completely free, where quizzes for every subject, all-in-one sessions, special topics in various subjects, and daily practice problems, PYQ series for many subjects you can find on my profile. This is my profile, unacademy.com/DevaGateCSE, and you can use my referral code to get an access to free classes on Unacademy, DEVALIVE. Yeah, good evening Golu. How are you? Yeah, thank you Arpan. You people are encouraging, great. Guys, please like the session. Yeah, please, everybody should like the session. That makes, great. Everybody, please like the session, guys. Fine. In case if you are not using app, using your mobile, go to Play Store and search for Unacademy Learning app and install it, so that you can right away access the classes, free classes of Unacademy. In case you require referral code, use DEVALIVE. Yeah, who are going to teach, and many more are there. And these educators are top educators, India's top educators, and they are going to handle most of the courses, and you will be access to all the courses if you take the subscription, or you can visit Unacademy for free classes too. And How do you visit? Unacademy.com, or you can install the app. Choose your goal, GATE and ESE. And before that, login. In case you require a code, enter DEVALIVE. And in case if you want to search any course, you can search here. And in case if you want to take the subscription, click on this. You will be redirected to plus or iconic plans. Choose as per your convenience. As I told, the plus and iconic benefits, choose any one of them as per your requirement. And if you are choosing the plus, look at the prices before taking the subscription. For 1 year, you have 27,225, but it is more than this. But don't forget to enter DEVALIVE. Then you will see the total price as 27,225. Right. Similarly, 1.5 year, 34,650, 2 years, 39,600 after applying referral code. Similarly, Iconic also has a different price for different plans, like 1 year, 2 years. I'm talking about 45,225, 66,600 after applying referral code. So choose as per your interest. Yeah, good evening Anvisha. Good evening Nikhil. How are you everyone guys? Doing good? Doing good? Yeah, these are the recent announcements from Unacademy. New batches for CSE already started, and ME and CE from 28th onwards are going to start. If you have any friends, you can refer this dates so that they may be interesting. They may be interested for joining Unacademy Plus or Iconic. So CS and IT will announce soon. Okay, these are the free classes that I have taken today, guys. And as an educator, I'm taking more classes to give you an access to Unacademy. Right? Look at that, how many classes I was taking, except this class. All classes are absolutely free to access. And I came twice to YouTube to deliver some content to you, and remaining all the classes that are Unacademy. Yeah. And you can visit any class as per your convenience. But I keep on taking the classes to get the benefit to the student, and I keep on working for you as hard as possible. But you will know when you access to the free classes what I deliver. Alright. If you are enjoying these sessions, definitely you will also enjoy other sessions too. Fine. Let's begin. And if you have not liked the session, please do that, guys. One more time request. I can see the likes are less than the live users. Many people are not yet liked, guys. Please do that. Thank you so much. Okay, in previous sessions, we have looked at undecidability concepts. Like, what is? Right, today we are going to see undecidable practice. In this previous sessions, we have learned what is decidable language and problem. What is RE but not recursive language and problem? What is not RE language and problem? Definitions only, remember. And these three are important, means very, very important. If you know them, automatically you can answer other two. This can be derived using above three. Whenever you see these are the answers of the questions in the exam, you can answer from what you get. This can be derived from your conclusions. First to find out, is it decidable or RE but not recursive or not RE. Later on you do, is it semi-decidable? RE means semi-decidable. Right? Is it semi-decidable or undecidable? Later on you decide. I hope you remember all the definitions. Right? If answer is decidable, you can say semi-decidable. If RE but not recursive, that is also semi-decidable. Everybody? And not RE language. Everybody? Undecidable language. Not RE is undecidable. Even RE but not recursive is also undecidable. These conclusions you can do later. Yes. But first know definitions, then you can conclude. That is the reason we have completed very, very important session in the previous classes. Right? I recommend you to watch the previous session 1 or 2 times to understand the words. Okay. Let's begin. How we are going to apply the definitions that we had in the previous session. Everybody? And we don't know what this problem, but we have to learn what is it first. Membership problem. What is membership problem? Right? What is membership problem? This problem can be applied for finite automata, can be applied for DPDA, can be applied for PDA, can be applied for alternating Turing motion, can be applied for Turing motion, and this problem can be applied for various domains, various classes. Now first I will help you first how to apply for finite automata. Then we will slowly learn how to apply for others. Everybody? So now my question is changed. Membership problem for finite automata. And this problem changes for PDA. Concept is same behind. Yes, what is membership problem? Guys, in the exam, membership problem for regular languages is decidable or undecidable. That's all. Now concept we will apply now. What is membership problem? What is it? Here the question is for given finite automata and for given string, we need to verify whether the given string accepted by given finite automata, both are given to you, whether string is accepted by finite automata or whether finite automata accepts a string. You can write two ways, whether finite automata accepts that string. Everyone, this is the problem. Here most of the time is not mentioned what is given. You have to understand finite automata given, string is given. So we are asking the question, is given finite automata accepts given string? Everybody, first understand the problem. First understand the problem. What is given to you? There are two things are given to you. One is the string, other is the motion. Both are given to you. Can you check this string accepted by this finite automata? Everybody? So question is very simple. Is W belongs to language accepted by finite automata? Look at the problem, only so many ways to say. Is W accepted by finite automata? Everyone? How many you have? So many. Is W belongs to language generated by LLG? Is algorithms may be different, but the concept is similar. If one is decidable, all are decidable, guys. RLG. And is W belongs to language generated by regular grammar? Is W belongs to language generated or described by regular expression? Doesn't matter which question you ask. Or is W belongs to given regular? Everyone? Come on. All are just membership problem for regular languages. Regular language is described by either finite automata or LLG or RLG or regular grammar, regular expression, or simply you can say regular language. First understand what is membership problem. Everybody understood? Everybody understood? Up to starting your problem. Just I am telling what is the problem. What is the problem here? Now we have given finite automata means what? Either DFA or NFA, epsilon NFA, doesn't matter to us. This may be DFA, this may be NFA, this may be finite state motion, we can speak. All are same, guys, remember. Only we represent different way, but all does same. And input, one input is finite automata, this is input 1, other input is string. String, that might be W. This is another input. There are two inputs to this problem now. We have a problem. We want to solve this problem. Here is string is a W, belongs to language accepted by given motion. M is a finite automata. Assume this is your M. Right? Motion is given, string is given. Like both are given to you now. But motion, I may give anything. Now this minute I will give you DFA1, next minute I will give you DFA2, but algorithm should be same for both. Then we say it is decidable. Everybody. Now, the answer may be yes or no. That depends on the machine. But what logic we are going to prove? Yes means W belongs to or W accepted by FA, given FA. W accepted by given FA. And no means W not accepted by given FA. And I'm theoretically speaking, guys. Look at my logic is, if really W accepted by given FA, now I can build HTM. HTM exists to prove this. What kind of HTM? It halts in both sides. How it verifies? HTM, that is a Turing motion. It is a Turing motion that always halts. I'm going to show how it is always halts. Whether the given finite automata accepts or not, I don't care, but it always halts. How? I will check. If W accepted by given finite automata, then given finite automata halts at final after running the string on that machine. Theoretically I am speaking, guys. After reading W. And if it is not belongs to the language accepted by given machine, then given finite automata halts at, you can convert to DFA. DFA you can convert any finite automata. I will check on DFA. If given DFA halts at non-final, after reading the string. Over. That is not accepted. This is the logic. This logic can be verified even there are so many algorithms. We have a CYK algorithm to prove it. You can convert finite automata to context-free grammar and you can use a CYK algorithm to prove this. Everybody, now tell me. And Swipe, you said undecidable. Tell me now, is it halting always or not? Can you halt for yes or no? Yes or no? Is there any case that you never halt? Is this Turing motion never halt? Come on. A given finite automata, I am going to run a string on this motion. If it is accepted, definitely we know where it halts. If not accepted, we know where it halts. After some time, we definitely halt. Is that clear? That is the meaning of logic exists for us. Because I am showing exactly logic exists for both. And you want to understand. Everybody? This is the logic to halt always. Halting both sides. I am showing it. My Turing motion halts whether given FA accepts or not. I am showing it. I am showing Turing motion halts because finite automata halts. Everybody? Come on. Given Turing motion always halts. Not given. The new Turing motion that we have designed, that always halts. Actually what we are doing? Given finite automata. What? Finite automata. And also given string W. Both inputs are there. And we are building a Turing motion that always halts. For S I know we are proving always halts. It means this TM is HTM. That means this problem is decidable. Everybody? So that is what we say, this membership problem is decidable. How did I say that? I proved that I have a Turing motion that always halts. इसके लिए दूसरा algorithm है guys. I can show you one more algorithm if you really wanted it. Give me finite automata. I can convert to context-free grammar always. You can write a CNF CFG for it. We have a CYK algorithm. It will also take a string. CYK algorithm, it also takes a string W. And CYK algorithm exists to verify the membership problem, to verify the given string accepted by given FA or not with the help of context-free grammar. CYK algorithm runs in order of n cube if n is the length of the string, guys. The CYK algorithm is a bottom-up parsing algorithm. I have explained in this TOC course only, one day I have explained CYK algorithm to you. But I didn't explain how to convert from finite automata to context-free grammar. But we have algorithms like we can convert to PDA, we can convert to context-free grammar. bottom up parsing algorithm. This is the algorithm, guys. Everybody, if you really wanted to show to somebody, this is how we can show that why this problem is decidable. I can show you an algorithm which always solves whether the string belongs to or not. But we always speak theoretically to understand, guys. That is why undecisibility looks very difficult. First, word we don't understand. Then definition we don't understand. Then we don't understand the intention of the problem. 3 things are there in our chapter now. 3 things. Always remember me. Why we lack at this chapter? Word we don't care. Once we understand the word, then definition we don't care. If you understand the definition, then look at the meaning of every problem. Problem you need to interpret. What is the given problem? You don't understand. Once you understand, do you have a logic or not? What logic you apply? That is how we struck. And you need to get one by one. Everybody? Right. Let's move on one by one. Can I say now onwards? Membership is decidable for regular languages. Over. Membership is decidable for regular languages. Or regular expressions. Or regular grammars. Or finite automata. Or DFA, NFA. All S. Clear? आज के बाद आपको कंफ्यूजन नहीं होना चाहिए व्हाट इज द मेंबरशिप प्रॉब्लम फॉर फाइनाइट ऑटोमेटा. रिमेंबर दैट. अगर पीडीए बोल रहा है सिर्फ नाम चेंज करो, ये फाइनाइट ऑटोमेटा को चेंज करो, पीडीए डालो. एवरीबॉडी आएंगे, बाद में आएंगे टू रिमेंबर. राइट. हॉल्टिंग प्रॉब्लम, ये डेफिनेशन क्या? व्हाट इज हॉल्टिंग प्रॉब्लम? द क्वेश्चन इज same whether given finite automata halts on given w, given string. This is the problem name. but ये नहीं बोलते हम, simply ऐसे बोलते हैं whether finite automata halts on w. इतना बोलते क्वेश्चन में. W means string, guys. समझ नहीं आता, ये डिजाइन कर रहा है, वेरीफाई कर रहा है, क्यों नहीं? यू नीड टू इंटरप्रेट प्रॉपरली. इसका मीनिंग क्या? इज फाइनाइट ऑटोमेटा halts on W. This is what I am asking. Can you understand? Yes, I know. The input is the finite automata, input is W. Everybody, and do you know finite automata always moves one direction? Did you face ever that it went to infinite loop? By definition, so many machines, halting machines like finite automata, DPDA, PDA, LBA, HTM, except Turing machine, all machines by default halting machines. All machines by definition they are halting because they never have a case never halts. By definition, all machines by definition they halt. Everybody clear this point? Halting problem. When I say halting for DPDA, सिर्फ ये वर्ड चेंज होता. इज गिवन डीपीडी हार्ट्स ऑन गिवन स्ट्रिंग. सिर्फ ये मशीन चेंज होता रहता गाइस. दिस इज द मशीन चेंज होता रहता, लेकिन द कॉन्सेप्ट बिहाइंड दिस प्रॉब्लम इज सिमिलर टू ऑल द मशीन्स. एवरीबॉडी क्लियर? एंड आज के बाद व्हाट इज द हॉल्टिंग प्रॉब्लम? कंफ्यूजन नहीं होना चाहिए. मतलब एक मशीन इनपुट है, एक स्ट्रिंग इनपुट है, इसको डिसाइड करना पड़ेगा. ये मशीन भी दिया हुआ और स्ट्रिंग भी दिया हुआ. Can we check that machine halts on that W? Machine may be finite automata if you are applying for regulars. If you are applying for DCFLs, it might be DPDA. If you are applying for CFL, it might be PDA. So depends on the problem definition, keep on changing. Everybody? चल अब देखते हैं. Now can I say this is a trivial problem? This is a trivial problem. Why trivial, guys? Not much important. It's obvious. Why? Because every machine that I mentioned, every finite automata always halts. Every finite data always halts. There is no such case. Always this is going to happen. Always yes. Everybody, always halts. We'll never say no. Remember that. Give any machine, any finite data, give any string, I always say yes, I halt, because I don't have a case that I don't halt. Everybody, clear this point? That is the reason halting problem is decidable. It is, can I say now? It is decidable by definition. इसके लिए प्रूव करना जरूरत नहीं है by definition. Can we go to the next problem? Come on guys, can we go to the next problem? Exactly सत्यजीत, एंटायर दुनिया पता है वो डीएफए हमेशा हाल्ट ही होता, डीएफए नहीं, एनएफए, डीपीडीए, पीडीए, एलबीए, एचटीएम तक सारे हाल्ट ही होता. दैट इज द रीजन हाल्टिंग प्रॉब्लम डिसाइडेबल टू ऑल एक्सेप्ट ट्यूरिंग मशीन. यही तो होता कॉन्सेप्ट. ओके नेक्स्ट. नाउ emptiness problem guys, emptiness problem. What is emptiness? For finite automata we are talking about, remember that. Our regular languages we are talking about, or we are talking about regular expression, or we are talking about LLG, or we are talking about RLGs. Everybody, or we are talking about grammar, regular grammar, you can say that. What is the problem? Is directly I am writing the question. Is finite automata accepts empty language, remember that. This is the question. What are given to you? What are given to you? Only one, sorry, अभी दो नहीं input नहीं है guys, sorry, this is a different problem. Only one finite automata. Input is a finite automata. क्या चेक करना है आपको? What do you have to check? Is language accepted by finite automata equal to pi? This is the problem. Now we have two things. Yes, no, we have to think about it. Yes means okay, finite automata accepts empty. That means language accepted by FA is equal to pi. No means language accepted by finite automata not equal to pi. Is it clear? Accepts empty means yes, not accepts empty means no. Everybody, इसको कैसे करें हम guys? बहुत वैसे एक algorithm लिख लेते इसको लिए. Algo 1, what I should do, you give me any finite automata, I will convert to minimum DFA using my algorithms. You give me expression, you give me LLG, RLG, सबको minimum DFA consider कर सकते हैं. And then check now. Now what do you have to check? What do you have to check? Check final states. Check final states. Yes means, how do you say yes now? Yes कैसे बोल सकते हैं? If there is no final, if no final exists. No means at least one final is there in that machine. If at least one final exists. Everybody, yes, दोनों के लिए लॉजिक है. yes भी बोल सकते, no भी बोल सकते. मतलब हमको पता है given finite data how to verify whether it accepts empty language or not. But we are not designing FA that accepts pi. Remember that. We are verifying. Designing is different, verifying is different. Clear? इसीलिए बोलते this problem is also decidable. इसके लिए भी लॉजिक है. And we also have a logic for no. We can halt for both. But there is another algo guys. There is another algo. I didn't tell you, but I'm writing it. Algo 2. Given finite automata, you can convert to PDA. And PDA you can convert to context-free grammar. And context-free grammar you can simplify. Of course इतना ज़्यादा ज़रूरत नहीं है, फिर भी कर रहा हूँ क्यों ये algorithm बाद में यूज़ होगा PDA के लिए. Simplify CFG. Simplify CFG. If there is any production left, non-empty. No production left, empty. Everybody, and simplify the CFG. Now look at नो प्रोडक्शन लेफ्ट, ऑल प्रोडक्शंस आर डिलीटेड, मीन्स एक प्रोडक्शन भी जरूरत नहीं है ग्रामर में. नो प्रोडक्शन एग्जिस्ट, दैट मीन्स यस. प्रोडक्शन एग्जिस्ट एटलीस्ट वन, मतलब नो. दोनों के लिए लॉजिक है. एवरीबडी, मतलब ये प्रॉब्लम, वन प्रॉब्लम कैन हैव मल्टीपल एल्गोरिथम्स. वन प्रॉब्लम कैन हैव मल्टीपल एल्गोरिथम्स. देख लेना गाइस. ऐसे इफ यू आर स्टडिंग एल्गोरिथम्स, यू नो सॉर्टिंग प्रॉब्लम, इट्स अ वन प्रॉब्लम राइट. सॉर्टिंग प्रॉब्लम है, इसके लिए लीनियर सॉरी क्या है, इंसर्शन सॉर्ट, बबल सॉर्ट, क्विक सॉर्ट, मर्ज सॉर्ट, हीप सॉर्ट, कितने सारे एल्गोरिथम्स है सॉल्व करने के लिए. पर टाइम कॉम्प्लेक्सिटी अलग होगा, स्पेस कॉम्प्लेक्सिटी अलग होगा. यहाँ भी ऐसे है. if the problem is decidable, in the world there might be multiple algorithms. At least you remember one of the algorithm to say it is decidable. Are you clear everybody? एक प्रॉब्लम के लिए आपके जैसे सोचना जरूरत नहीं, मेरे पास दूसरा एल्गोरिथम भी हो सकता, लेकिन समझना ये प्रॉब्लम डिसाइडेबल है नहीं. Can I say now emptiness problem is decidable? It is decidable for finite automata. Everyone, and also remember we have solved 3 problems so far. One is membership, another one is halting, another one is emptiness. Remember one thing, all these problems are decidable or not for finite automata. Everybody, all are decidable. Then complement also non-membership for finite automata. यहाँ पर is W belongs to L of F देखेंगे, यहाँ पर क्वेश्चन बदलता, not belongs to देखेंगे, yes no बनता, no yes बनता. बस ये डिसाइडेबल होगा तो वो भी डिसाइडेबल होंगे. रिमेंबर halting मतलब नॉन halting भी डिसाइडेबल होंगे. emptiness means non emptiness भी decidable होंगे. Everybody, so it's not 3 problems we have learned, 6 problems. Just S को no बना दो, no को S, then it is a complement of the problem. Everybody, if this is the problem P, then this is the problem complement. Everybody, if this is the problem 2, then this is the P2 complement. Not a language guys, is a problem, remember that. If the P is decidable, P complement हमेशा decidable, exactly like complement only. Yes, clear? Okay, let's move on. Next problem guys, next problem, finiteness. What is the finiteness for a finite automata? It means is given finite automata accepts finite language. इसका मीनिंग is language accepted by finite automata equaled finite set. ये था क्वेश्चन. एवरीबॉडी, पहले प्रॉब्लम को समझ लो, आंसर बाद में आएगा, नहीं आएगा बाद में. विदाउट नोइंग द प्रॉब्लम हाउ कैन यू से आंसर इज डिसाइडेबल और नॉट. पहले प्रॉब्लम ही नहीं आता, इनको आंसर चाहिए डिसाइडेबल अनडिसाइडेबल, नहीं होता. एवरीबॉडी, इसका इनपुट है सिर्फ वन ही है, फाइनाइट ऑटोमेटा. We give any finite automata in the world. Do you have any algorithm to decide that? Yes when we say, no when we say. And guys, remember, I'm going to teach this for 2 days, 3 days, but you do not know, this might require even 10 to 20 hours to understand. That only I thought on plus course on Unacademy. Remember, I'm going to teach all the concepts, but there are so many concepts are there and I cannot handle within 3-4 days, but I will give you maximum content that you require. Yeah, yes, exactly. Who is that? Yes, what is the algorithm guys? Algo, we are creating algo now. What is algo? Algo 1, there are two algorithms, remember. Algo 1, take the finite automata, convert into minimum DFA algorithm है उसके लिए, and then check for loops, self loop or cycle other than the dead state. Dead state तो वही दिखता, other than dead state वो it is not correspond to language. Other than the dead state, check for the loop. If loop exist, मतलब पक्का infinite language होगा. देखो ऐसे है, ये loop है, accepting right, infinite language. अगर ऐसे है प्रॉब्लम a, b, now loop नहीं है, don't look at the dead state, no loop exist, सिर्फ एप्सिलॉन एक्सेप्ट कर रहा है finite language. When there is no loop, finite language. That means if you want to say loop, yes. If no loop, if loop exists, infinite language. Clear? That is the algorithm. But don't look at a dead state. Dead state correspond to invalid strings. Language की बाहर गए बात वो. Everybody? Check for the loops. If loop exists, then infinite language, like I can say that language accepted by finite automata is finite. S means. No means language accepted by finite automata is infinite. Not finite means infinite. Everybody? Yes. It is decidable. Everybody clear? कोई डाउट है अब तक? अब तक हम 4 प्रॉब्लम मतलब 8 प्रॉब्लम सॉल्व किया, इसका कॉम्प्लीमेंट भी इनडायरेक्टली सॉल्व किया. कोई दिक्कत है अब तक? सही डायरेक्शन में जा रहे हैं हम? मतलब बहुत जल्दी किया हम. 8 प्रॉब्लम नहीं होता था मेरा से, मैं बीटेक में था ये वर्ड ही समझने आता था. इसके बाद जाके देखो, इसके बाद कहीं पर भी जाके देखो, इस वीडियो से किसी वीडियो से कंपेयर करो क्या बोल रहा है लोग. इफ दे वांट टू से अनडिसेबल डिसेबल, टेबल यूज करते लोग, डेफिनेशन नहीं बताता. बट यू हैव टू रिमेंबर द टेबल, बट टेबल के अंतर नहीं समझ में आता. एवरीबडी, आई एम ऑल्सो गोइंग टू क्रिएट द टेबल, बट उसमें कुछ नहीं रहता. प्रॉब्लम का डेफिनेशन पता नहीं, क्यों डिसेबल पता नहीं, क्या अल्गो यूज करता पता नहीं, बट लेकिन डिसेबल तो है. राइट? And remember this algorithm, you will never forget is it decidable or not. All the decidable problems they have algorithms. Remember that point. All the decidable problems they have algorithm. When it is undecidable, then we get much difficulty. Tomorrow we'll deal that. Yes, निखिल मेरा वीडियो से कंपेयर मत करना यार, ठीक है. Now there is algo 2. There is algorithm 2. किसको पता? Anybody knows algorithm 2 also there? Finite automata, you can convert to context free grammar. You can draw dependency graph. एक ग्राफ होता dependency graph over the non terminals of the grammar. उसमें भी लूप चेक कर सकते हैं. Check for the loops. Loops दो साइड चेक कर सकते हैं हम. Everybody? बट डिपेंडेंसी ग्राफ क्या है वो अलग बात है. आप कॉन्टेक्स्ट फ्री ग्रामर में आप बाद में देखेंगे. एवरीबॉडी, दिस एल्गोरिथम 2 एग्जांपल. इफ यू वांट आई विल टेल यू गाइस, दिस इज योर व्हाट कॉन्टेक्स्ट फ्री ग्रामर. यस और नो? यस, ये एवरी नॉन टर्मिनल कंस्ट्रक्ट द नोड. यस डिपेंड्स ऑन ए, एस डिपेंड्स ऑन बी. ऑर्डर जरूरत नहीं. एस डिपेंड्स ऑन ए, एस डिपेंड्स ऑन बी. कोई लूप है? नो लूप. मतलब लैंग्वेज भी फाइनेट है. L is language is a finite. Language generated by this grammar is a finite. But first convert the finite automata to context free grammar to decide this answer. Everyone, आपको पता है language is just A B. अगर आप ये मान लो S A or B, just look at this. Just look at this. Yes is a node, only one node. It depends on itself. Loop exists or not. अब देखो ये infinite language है. It represents infinite language. Understood? This is another algorithm. Algo 2 I am trying to tell you. But before that, given finite automata convert to context-free grammar. We can do that. We can do that. We have algorithms too. And there are many other algorithms too. Remember that. You don't need to come to control for graph. Sorry, context-free grammar. You don't need to come to context-free grammar. You can convert finite automata to even left linear grammar or right linear grammar. You can also consider dependency graph for them. Right? So many algorithms are there to decide this problem is decidable. Yes, hello Devraj, late today. Yeah. Right. Clear? Okay. Now totality problem. Totality problem. Everybody remembered so far? एक बार रिवाइज भी कर लेते हैं. Membership. दूसरा problem, halting. Revising is very important. Halting. Another problem we have seen. Another problem, emptiness. Recent problem, finiteness. And for finite automata we are applying. Don't forget that. And how do you check membership? Okay. Run a machine. If it all set final, accepted. All set non-final, not accepted. That is a membership concept. Algo exist. Algo exist means decidable. Algo exist means it can say logic exists for both yes and no. Algo exist means yes and no have logics. Remember, algo word is very dangerous here. Yeah. Halting by definition. By definition, it is decidable. Emptiness, we have two algorithms. In the minimum DFA, check for finals and non-finals. Check for final states and non-finals over answer. That is algorithm. And finiteness, check for the loops other than the dead state. Over. Look at, we have something to speak about algorithm. Everybody, all the decidable problems, they have something to speak about. Can we go to the next one? Come on guys, keep please like the session if you have joined late. Right. Come on, next one. Totality. What is this totality problem? Why people say totality problem? Because we are looking for something. What is given finite automata accepts sigma star. It means we are verifying is language accepted by finite automata is equal to sigma star. Everybody guys, is given finite automata accept sigma star. There are so many algorithms are there again. So many algorithms guys. Just think about one algorithm enough. What is input? Just finite automata. This is your input. And what you have to verify? S means, okay, that given input accepts sigma star. Means language accepted by given input is equal to sigma star. No means language accepted by finite automata, don't say equal to pi. That's wrong. Not equal to sigma star. No need to be pi guys. No need to be pi. Remember that point. Right? If you assume sigma is equal to A, then sigma star is A star. Right? Now language accepted by finite automata is A plus. That means it is not equal to sigma star. It is not totality only. Remember, careful. Don't do pi. Pi is not a problem now. First mistake the student does, complement, they try to think about empty language. No. Sigma star complement is empty. But not this problem. This problem complement is not equal to sigma star. Everybody? L is equal to sigma star question mark. Iska complement hai not equal to sigma star hota. Everybody? Problem. Ye English problem. Statement hai. Clear this point? Understand. Please don't do equal to pi. That's wrong. No means the given machine not accepting sigma star. Clear? Come on guys, come on. I'm waiting for. Yes. अब बताओ algo 1. First take a finite automata. Can you convert to minimum DFA? I can compare minimum DFA. I have an algorithm to check equality. Minimum DFA always looks like this one. If it is accepting whatever the symbols you have, A, B, C, if the sigma is equal to ABC, always one state that is the final. In the DFA, minimum DFA has only one state that is also final. And that too final. Yes or no? कोई भी फाइनाइट बेटा देना NFA, epsilon FA जो भी है, we have an algorithm to convert to DFA and we have an algorithm to convert to minimum DFA. Then minimum DFA should contain only one state and that should be final. Then that accepts sigma star. Everybody? And that is logic. Everybody? Logic exists. And suppose not accepting sigma star, you may have a one state but that may not be final, or you may have more states, then that is also not accepting sigma star. Only one final is not enough. Machine has only one state and that too final. Remember that. After minimizing DFA, the machine has only one state and that too, that is the final. Just don't say only one final state. Wrong, Anvesha. Everybody, the machine, बताया ना दुनिया में क्या होता? Sigma star has unique minimum DFA in the world. Unique minimum DFA. If really this DFA1 and DFA2, if they are accepting sigma star, both should come to, after applying minimization algorithm, they should come to this only. Like let's say AB. यहाँ पर कुछ और हो सकता? ऐसे हो सकता? ऐसा नो? ये भी है और दो फाइनल है but दोनों सेम है. After minimizing they should look like same. This is a unique motion to represent sigma star in the world. This represents sigma star if the sigma is A comma B. Yes, exactly. Fine. Clear? Yes के लिए लॉजिक है, नो के लिए लॉजिक है. That is the reason decidable. But there is another technique, guys. There is another technique. It will help you later on. Algo 2. What are you asking? Is language accepted by finite automata equal to sigma star? Is it same as is complement of this one is equal to pi? Check करो guys. ये सही में नहीं है. This machine is accepting everything. इसकी complement must be no string. शुभश्री, वो DFA नहीं है ना? DFA पढ़ के आ जाओ. पहले. मैं क्या बोल रहा हूँ? मिनिमम DFA. कोई डिजाइन किया दुनिया में अब तक ऐसे DFA? ये DFA क्या है? ना DFA. सिग्मा नेवर बी एम्प्टी. कोई ना कोई तो होना चाहिए. ये इज मिसिंग. कहाँ जाओगे? ऐसे नहीं होता मशीन. नो ट्रांजिशन होता क्या? ऐसे कब डिजाइन किया DFA? Every state for every input symbol exactly one transition. Come on. कुछ भी बोल दो क्या? कुछ भी बोलोगे? चलो आगे चलो, जल्दी चलो. Can I say this? Everybody, now I have another way to speak. Algo 2 I am trying to design. Why do I want to verify finite automata? I will not. I will do some other. How? Look at guys. आप तो finite automata दे रहा है. मैं क्या करूँगा अंदर? इसको DFA बना दूँगा. Right? Of course this accepts what? Let's say L. DFA also accepts what? L. मैं इसको new DFA बना दूँगा. पता है ना आपको? क्या करना guys? New DFA, final and non-final interchange करो. This accepts what? L complement. इसमें check करो final है नहीं, final state, check final states, enough. No final state means empty. S means no final state. No means at least one final. Everybody? अरे देवराज दिमाग अप्लाई करो यार, मैं क्या बोलूं आपको, मैं नहीं बोल सकता हूं आपको। क्या सिग्मा स्टार हैज पाई यार, ये क्या बोलूं यार इनको। सी दिस इज ए DFA. What it accepts, guys? This DFA accepts what? Accepts what? Sigma star. ऐसा नो, here L is equal sigma star. L complement क्या होगा? हमेशा पाई होंगे ना, पाई होंगे ना. If you ask is L equal sigma star, I don't do that. I do some other way. Is L complement equal to pi? दोनों सेम है, तो समझ लो यार, ये प्रॉब्लम है. सिग्मा स्टार की कॉम्प्लीमेंट नहीं कर रहे हैं हम. कमान कमान, ये डाउट ज्यादा हो गया इनका. राइट एवरीबॉडी, चलो चलो आगे चले यार. मिनिमम ही करो यार, मिनिमम ही करो, मिनिमम ही करो, कुछ नहीं होता. क्लियर दिस पॉइंट? This is another way to speak the same problem. I am asking about finite beta. You do the machine that accepts the complement of the given language machine. Remember that, right? ये same है. If and only if बोलते इसको. ये भी अलग चेक कर सकते, algo 2 भी बना सकते by looking at the complement of the language. Everybody? या एम्प्टीनेस में कन्वर्ट किया. एम्प्टीनेस ऑलरेडी डिसाइडेबल ना, तो ये एम्प्टीनेस प्रॉब्लम बना दिया. सो यू कैन कन्वर्ट टू एम्प्टीनेस. दिस इज एम्प्टीनेस प्रॉब्लम. एम्प्टीनेस प्रॉब्लम ऑलरेडी डिसाइडेबल, सो यू कैन से टोटलिटी इज डिसाइडेबल. ये इंटरलिंक कैसे है? इंटरलिंक है गाइस. एवरीबडी, बट बी केयरफुल, बी केयरफुल. नॉट एवरीबडी इन द वर्ल्ड. फॉर फाइनाइट एलिमेंट आई एम टॉकिंग अबाउट. फाइन, लेट्स मूव ऑन, लेट्स मूव ऑन. Now equivalence problem. Equivalence. What is equivalence problem? Is given FA1 and FA2, कोई भी FA1 FA2 accepts same language. Is a question. Is that no machines accept same language? इसको क्या लिख सकते हैं? Is L of FA1 equal to L of FA2. ये प्रॉब्लम है गाइस. इनडायरेक्टली is FA1 equivalent to FA2. Clear? Okay. What is the input? Now there are two machines, FA1, FA2. Any two random machines in the world which are finite automata. Now do you have any algorithm to check? If you have an algorithm, show me what is the logic for S. Show me what is the logic for no. कुछ भी आपके पास algorithm है तो अप्लाई कर दो, halting, non-halting जो भी चाहिए. Alright, everybody. FA1, FA2. How do you check, guys? Anybody guess? Anybody? How do I convert these two finite beta into something that I can check? Are they accepting same or not? Yes, good point, Devraj. Have same minimum DFA if they are accepting same language. So algo क्या है? Take the two FAs, FA1, FA2. Convert minimum machine, minimum DFA1 and minimum DFA2, and if they are exactly same, they are isomorphic, exactly same, when you remove the labels, state names, that's all, state names, exactly same means if exactly same, if they are isomorphic, then accepts same language. If you see at least one transition is different somewhere, then they are not accepting same language. That is algorithm exactly. Yes, graph isomorphism. Yes, graph isomorphism. Check it. शुभश्री रेगुलर एक्सप्रेशन भी चेक कर सकते, क्यों नहीं? क्यों नहीं? रेगुलर एक्सप्रेशन ले लो, 1 है. दूसरी रेगुलर फाइनाइट ऑटोमेटा ले लो, चलेगा. इसको भी कर सकते हैं हम. क्यों? रेगुलर एक्सप्रेशन को NFA कन्वर्ट कर लो, NFA को DFA कर लो एंड मिनिमम DFA करो, और इसको भी ये 1 1 कर लो और इसको मिनिमम DFA 2 बना लो. ऐसे सेम चीज चेक कर लो, ये दोनों सेम है नहीं? ओवर. एवरीबॉडी, आप कुछ भी कर सकते हैं. एक रेगुलर एक्सप्रेशन, एक रेगुलर ग्रामर, 2 रेगुलर एक्सप्रेशंस, 2 रेगुलर ग्रामर, कुछ भी. एवरीबॉडी, yes I know decidable. ये क्वेश्चन ऐसे था, लैंग्वेज जनरेटेड बाय रेगुलर एक्सप्रेशन is it same as language accepted by finite automata? You can do that. Clear? Right? Yes, you can do that. Believe me that finite automata can be grammars. You can replace them. You can replace with the languages. You can replace with one is expression, other is grammar. It's your choice. Can I say it is also decidable, guys? Right? Yes, decidable. Yeah. There are other algorithms. I'm explaining only one. There are algorithms to do this. Remember, there are other algorithms too. Let's move on. Disjoint problem for finite automata. What is this disjoint problem? Here is language accepted by finite automata 1 intersection language accepted by finite automata 2 equal to pi. This is the problem. Everyone? Yeah, that is a problem. Let me write another one. This problem also called as intersection empty. Intersection is empty. Is intersection empty problem. What is that? Is language accepted by FA1 intersection language accepted by FA2 is equal to pi. That is a disjoint, right? Everybody knows? That is a disjoint, right? 2 languages are given to you or 2 machines are given to you. They represent languages somehow. And how many things are given to you now? Two inputs. 2 inputs. Finite automata 1, finite automata 2 are 2 regular grammars or 2 expressions, or one is the machine, other can be expression. Yes. Yes means they are disjoint. S means they are disjoint, means they don't have a common string. No means they have at least one common string. Everybody? S means no string, no common string accepted by both. If one accepts, other doesn't. No means at least one string accepted. Everybody? At least one string accepted, not equal pi means accepted by both. Common string, at least one common string exists. Yes, exactly. What is algorithm? We are having this algo strategy. FA1, FA2. What do? DFA बना लो पहले DFA बना लो, बेस्ट होंगे DFA, मिनिमम ही बना लो चलेगा, और इसको कंपोजिशन करो DFA1 cross DFA2, and this machine we can check for intersection. We have logic to check in the composition, right? You can check. This is a new machine. Just check. Assume this accepts or whatever it is. Design for intersection. Design for intersection. Design. This accepts intersection. If equal to pi, equal to pi means if no final exists. No final means equal to pi. If there is a final state, means something is common to them, not equal to pi. Yes, Devraj, that is also correct. Intersection minus कर सकते, yes. Everybody, and if you know the composition, then only you can understand. But believe me, this is a fact. If you don't know composition, don't ask me now to design. But we did in the beginning how to do the composition of two machines. We did that in TOC course only. Right. Clear? That means yes has the logic. No also has the logic. So we say this problem is decidable. Right. Now move on to the next problem, guys. Set containment. बहुत लोग को पता नहीं है ये सबसेट क्लोजर प्रॉपर्टी अलग है, डिसीजन प्रॉपर्टी अलग है. ये सबसेट चेकिंग है, ये भी सबसेट है, बट क्लोजर प्रॉपर्टी नहीं गाइस. सबसेट चेकिंग, we are going to check the subset. But what is language of FA1 subset of, or equal also you can do, language accepted by FA2. It's not a closure property, remember. क्लोजर प्रॉपर्टी अलग है. क्लोजर प्रॉपर्टी में इनपुट एक ही मिलता, राइट. सबसेट ऑफ अ गिवन लैंग्वेज वी डू. हियर वी डोंट डू दैट. टू लैंग्वेजेस आर गिवन, वी विल चेक वन विथ अदर. एवरीबॉडी, इसका मीनिंग क्या है? एनीबॉडी गेस? दूसरा है प्रॉब्लम. गाइस अज्यूम ये L1 L2 के अंदर है. सपोज ये L1 L2 के अंदर है, क्या होता गाइस? सपोज L1 इज इनसाइड L2, इसका मीनिंग है L2 बाहर, L1 एक स्ट्रिंग भी नहीं होता. कैसे लिखते हैं उसको? L1 इंटरसेक्शन L2 कॉम्प्लीमेंट इज पाई. रिमेंबर दिस डेफिनेशन गाइस. L2 से बाहर L1 का एक स्ट्रिंग भी मैच नहीं होता. क्यों? पूरा L1 L2 के अंदर है. एवरीबॉडी, L1 L2 may be equal, that's okay. Can I say this? Saying the subset another way, guys. This was my interview question in PhD at ISE Bangalore. Everybody, prove the subset using intersection and complement. Because you can check that. Outside L2, is there any L1? No. That is how do you write? Outside L2, there is no common string with L1. Okay, fine. Let's move on. This is same as is language accepted by FA1 intersection language accepted by FA2 complement. You have to prove equal to pi. Guys, two machines are there, FA1 and FA2. And do you know other way to do? Guys, the complement of a language, a complement of regular, again regular. इसके लिए दूसरा मशीन होंगे ना, FA3 होंगे ना इसके लिए, राइट. यू कैन डू दैट बाय इंटरचेंजिंग फाइनल नॉन फाइनल. इंटरसेक्शन के लिए दूसरा मशीन है ना, कंपोजिशन FA13. इसको इतना चेक करना है इक्वल टू पाई. ये एम्प्टीनेस प्रॉब्लम है. एंड वी आर यूजिंग 3 algorithms. Complement, how to do regular language, how to do the regular language complement, how to do the intersection of two machines to accept intersection of two languages, and how to check the emptiness of this compound machine. Everybody? Yes, L1 minus L2. That's good. Everyone? Yes, this is also, we have a logic, because all of them we have logics. So this problem is also decidable. Can I say that? Now no need to prove it, because everything you have an algorithm. Complement you can do using algorithm. Intersection you can have an algorithm. Emptiness other algorithm is there. All of them you have algorithms. You can prove this. Yes. Reduced to disjoint problem. Good. यहाँ पे disjoint हो गया. ये disjoint है. और ये disjoint emptiness पे depend होता. You can reduce to even emptiness. And set containment is reducible to disjoint, reducible to emptiness. Yes, good point. Okay, now what we have learned, right? Just before conclusion, before list, guys, anybody do not aware of plus iconic, you do not know, Undisability have taken nearly 10 hours to explain these problems. 10 hours, remember. So that is the beauty of plus and iconic. What you are learning is a trailer basically. What you are going to learn in the plus and iconic is different. So you will have a structured courses, you have multiple courses, and you never imagine what you are learning there. So you have lot of content inside the plus and iconic which will give you confidence to learn some concept from us. Remember that. We are coming for 1 hour, we are helping to give, but remember my referral code. If anybody want to take the subscription or anybody want to learn from free classes, use this my referral code. That's all. Okay, now tell me guys, for regular languages, what are decidable? All are decidable. Yes or no? All problems are decidable. For what? Finite automata, or you can say regular languages, or you can say regular expressions, whatever you want to say, but talk about regular languages only. But apply carefully. Definition keep on changing. Yeah, clear this point? Okay, next classes I'm going to apply decision properties for DCFLs and decision properties for CFLs and decision properties for recursives, decision properties for RELs, and we are going to see from tomorrow. And thank you so much for attending today's session, and today's session is over. Tomorrow we'll meet at 4:30 and at 8:15. If I don't come at 4:30, please come at 8:15. The 4:30 session I may cancel tomorrow because of I have little bit urgent work, but day after tomorrow I will try to take, but 8:15 we will continue tomorrow again. Okay, yeah, please follow my profile to get the notification of my classes. Visit Unacademy and just click on follow to get daily notifications. Yeah, you can subscribe to our Telegram channel. Subscribe to this so that every day we will share the links before coming to the class, so directly you can come here. Yeah, these are various free YouTube channels from Unacademy, from top educators who are going to help you, who are going to help your friends, and please share these YouTube channels with your friends. And thank you so much. Please, one like is just, right? Sharing is the caring and like is the respect. Thank you so much, and subscribe to this channel if you are enjoying. Bye bye. Take care.